Hello everyone, I hope you enjoyed the conference in the beautiful New Zealand. Sadly, I cannot be there personally, but nevertheless, I would like to present you the results of the first strategy card game AI competition. But first, I will start with introducing the competition itself. Since a few years, strategy or so-called collectible card games are becoming a more and more popular research field. A number of papers focusing on search algorithms, mainly MCTS-based approaches to create an agent, and about developing the deck recommendation systems that will choose the right set of cards to play, has been published. Strategy card games are a challenging, thus interesting, domain because of the specific game features that make designing successful AI players especially difficult. Imperfect information, randomness, long-term planning, and large action space. Last year at CIG 2018, the first Hearthstone AI competition was organized with the goal to develop the best agent for the Hearthstone. To complement the Hearthstone AI competition, we proposed the Strategy Card Game AI competition, whose goal is to focus on more fundamental research and alternative game mode. Our aim is to encourage advanced research, free of drawbacks of working with a full-fledged game, in subject of game research, deck building, and in future also procedural content generation. Our competition is based on the Legends of Code and Magic, abbreviated to LOCM, a small programming game developed last year by me and Radek in cooperation with the coding game platform. The game has been designed with the goal of supporting AI versus AI games via the standard textual input-output interface. The game engine, as well as a few example agents, is available on GitHub. In its core, LOCM is a simplified version of the Elder Scrolls Legends with a limited number of keywords and abilities per card. So comparing to commercial card game engines, it is much simpler to handle by the agents, and thus allowing testing more sophisticated algorithms and quickly implement theoretical ideas. All card effects are deterministic. Thus, the non-determinism is introduced only by the ordering of cards and a known opponent deck. Also, LOCM is based on the 4-arena mode. Before every game, both players create the decks separately from the symmetrical yet limited choices. Also, no cards are drawn directly during the player's turn, and hidden information consists only of the opponent's hand, opponent's deck, and your own deck ordering. Given the current state of the board, it is possible to fully compute all possibilities and consequences within the horizon of one turn. So instead of allowing the agents to freely construct their own decks from all available cards, which in practice, as shown by Hearthstone competition, makes the bots choosing predefined human-designed decks, LOCM introduces the 4-arena mode. In this mode, both agents are given choices between some random cards belonging from the entire card set. Each turn of this so-called draft phase consists of picking one card from 3 available until the full deck is constructed. Both players are given exactly the same choices, and the picks of the opponent remain unknown. The cards of the game is pretty standard. Both players can play cards from their hands within the current limit of the mana points, and their goal is to reduce health points of the opponent avatar to 0. Cards are either creatures that occupy the board and can attack each other, or items, which can be used to buff friendly creatures, damage or destroy the opponent's creatures, or cause an effect aimed at the avatars. The current version of the game contains 160 cards. Every card may contain a subset of 6 Elder Scrolls Legend originated keywords, and additionally, when summoned, it may modify the health of the player, his opponent, or increase the card draw at the beginning of the next turn. An item, depending on if the target is a friendly or opponent creature, can add or subtract the keywords enumerated on its card. Because the set of available mechanics is considered close and was designed alongside its textual representation, all the expressible cards are easy to serialize and analyze by the player's program. Also, it allows the current card set to be an easy subject for further extensions. Before the current competition, the game has been used in 2018 for two contests organized by the Coding Game, the 24-hour marathon and fully fledged one-month competition in July, which gathered over 2,000 participants, students, seasoned programmers, and all other kinds of hobbyists. Since that time, we divided the board and, following test legends, introduced the second lane, which theoretically increases branching factor and favors deeper strategic thinking. Now let's finally talk about the competition itself. We have provided game engine and game runner that allows running a batch of games between the agents stored locally. Moreover, there's also an online testing IDE hosted by the Coding Game. Our competition requires agents to fulfill the default Coding Game requirements regarding communication protocol and the time limit of 200 milliseconds per turn, but we allow agents written in any programming language. Although using the online IDE is very helpful, it is not mandatory, as all computations for the competition were performed by us on the independent server. We have received 6 submissions, plus we also run 2 simple bots as a baseline. To evaluate the entrants, we made every agent play over 12,000 games. In particular, every pair of agents play against each other on 175 drafts. Every draft repeated 10 times with different deck scheduling and ordering of agents. Thanks to the IEEE CEC, the authors of the top 3 agents will receive prize money. We provided 2 different baseline agents. Bots try to perform almost all possible moves in a particular order. Only one of them understood the whole game. The second simply ignored items, but plays more aggressively. As expected, these agents performed worse, but still achieving 25 and 37% of wins respectively. 6th place, Conrisk, is a simple heuristic agent which ignores items. 5th place, UJI Agent 1 categorizes cards into a few sets based on their statistics and tries to fit predefined patterns during the draft phase. During play, it uses a heuristic but detects and applies little moves if possible. 4th place, Marathbot, heuristic agent which random card play. Board moves are selected by evaluating random simulations. Ignores blue items. 3rd place, Anti-Squid. During the draft phase, tries to fit a predefined pattern, kind of a mana curve. Already picked cards might affect the scoring. Plays with a complex, handmade heuristic. Also detects little moves. 2nd place, UJI Agent 2. Made by the team from the James I University in Spain. Categorizes cards during a draft into a few sets to define a probabilistic need for them. Fallbacks to random on ties. During the play, samples combinations of attack and summon use strategies. Finally, the 1st place, Coac by Victor Lee. It chooses cards based on a predefined ordering, plays with a minimax-like algorithm of depth 3 with alpha pruning. Dynamically limits depth if there is no enough time left or the tree is too wide. Also detects little moves and performs a simple evaluation of enemy turn. As we can see, the scores obtained by the agents seem stable as the number of games increases, and Coke won by a large margin. Congratulations! If you think the domain is interesting and you like it, I have a good news for you. You don't have to wait another year to participate in this competition. The second strategy card game AI competition will be held at the brand new IEEE COG conference this year. All the rules remain unchanged, and the preliminary deadline for your submission is 1st of August. For more information regarding the Legends of Code and Magic and related competitions, please check the game webpage. In case of any questions or comments, do not hesitate to mail me. Thank you for your attention. Please enjoy the rest of the conference. Goodbye.